All right, so I want us to go over the problems that we did in class. Really solving problems of electrical circuit. So what do we have here? The first problem is in the diagram below. R1 is 200 ohm and R2 is 400 ohm. So if 2 amp current passes through A1, what is the current through A2? So this one is our A1 here, and this one is our A2. So we are saying here we have a current of 2 amp. So we are asking what will be the current here. Now, we need to take note that this is a series circuit. This is a series circuit. And what do we know? In a series circuit, current is the same throughout the circuit. So what we are saying is there is no current divider. In that case, if A2, so if A1 has 2 amp passing through, it means A2 will also have the same 2 amp. So if this is 2 amp here for A1, this one is also 2 amp, because in a series circuit, current is the same throughout the circuit. So that's the first question. The second question is in the diagram below. R1 is 200 ohm and R2 is 400 ohm. If a voltage of 4V passes through R2, how many volts does the voltage source have? So we are saying 4V passes here. So this one has a voltage of 4V. But we know that this is 400 ohm in terms of resistance, and this one is 200 ohm in terms of resistance. So what we are saying is R1, or what we are saying is R2 is double R1. So R2 is equal to double of R1. That's what it means. So what does it tell us? It tells us that R2 is 2x, then R1 is x. So what you want to do is you can put x here and 2x here. So in terms of voltages, the voltage from source, which is this one here, is the addition of the two voltages from the resistors. So voltage from source will be equal to voltage for R1 plus voltage for R2. So what does this mean? It means that a series circuit has a voltage divider, or in other words, the total voltage of all the resistors in a series circuit is equal to the voltage source. So what we are saying is V, which is from the source, is given by this plus this. That is 2x plus x, which is equal to 3x. So the total voltage is 3x, but the voltage for R2 is 2x. Yeah, let me just make a change a little bit here. So the voltage for R1 is x, the voltage for R2 is 2x, and the total is 3x. Now, here, if we take 2x here, we know that 2x is equal to 4. Because it is given, we know that the voltage passing through R2 is 4 volts. So that is 2x. So 2x is equal to 4 volts, which implies that x is equal to 2 volts. So we are saying at this point, this resistor here has 2 volts passing through. Now the voltage source is 3x, as we have seen here that V is equal to 3x. So this is 2x, this is x, but this is 3x, because the voltage source is the additions of voltage from R1 and voltage from R2. So we know that each x is 2. So V is equal to 3x, which is 3 times 2, which is 6 volts. So the voltage passing through the voltage from the voltage source is 6 volts. But then this 6 volts is divided between the two resistors. Resistor 1 gets 2 volts and resistor 2 gets 4 volts. So in simple terms, we say that V is given by 2 volts plus 4 volts, that is from resistor 1, this is from resistor 2, to give us 6 volts, and this is the voltage source. Why are we doing this? We are doing this because it is a series circuit. So a series circuit has voltage divider, which means you need to add the voltages to get the total number of volts. Now let's move on to parallel circuit. In the diagram below, R1 is 200 ohm and R2 is 400 ohm. So if 2 amp current passes through AR1, what is the current through AR2? So we are looking at these ammeters. So AR1 is this ammeter. So we are saying we have a current of 2 amp in here. But we want to determine the current on AR2. So we are saying R2 has 400 ohm of resistance. R1 has 200 ohm of resistors. So one thing that we need to know is that the bigger resistor has less current passing through. So in other words, current, which is given by the symbol I, is inversely proportional to resistance, which means as resistance increases, current decreases. As the resistance decreases, current increases. So I'll just put up this. Current is inversely proportional to resistance. So what we are saying is, in terms of the current, the smaller resistor is going to have more current, and the bigger resistor is going to have less current. So if we start from here, if we start from let's say if we start from this point, let us call this point just big C for current. If we start from this point, current will move this direction and it will get to this direction. When it gets to this direction, it will divide. Some current will go this way, some current will go this way. So this current here passes through resistor 2, and this current here will pass through resistor 1. So the question is, if we have a current of 2 amp passing through resistor 1, what will be the current passing through resistor 2? And if we know that current is inversely proportional to resistance, immediately we know that a higher current, we know that higher current passes through resistor R1 because it has less resistance. So in this case, we expect the current in R2 to be smaller. So we expect the current in R2 to be smaller because R2 has higher resistance. So that's our expectation. So I'll just delete some of these. So I'll get rid of this so that I have enough space to write things on this diagram. So since R2 is double of R1, the current passing through R1 will give it a 2x. So the current passing through A1 or R1 will give it 2x, which means, as we said, we expect the current passing through R2 to be smaller. So this one will be x. The reason R1 is 2x and R2 is x is because the resistance R1 is half the resistor R2. So the bigger the resistor, the smaller the current. The smaller the resistor, the bigger the current. So R1 will have 2x and R2 will have x of current. So, and we know that the current passing through R1, AR1 is equal to 2 amp, and this is equal to 2x. What it means is that x is equal to 1 amp. So if current of 2 amp passes through AR1, it means current of 1 amp passes through AR2. So this implies that AR2 has 1 amp of current. But first you need to do you need to divide current. So what I'm saying is that a parallel circuit has a current divider. So what we are saying is if this one is 2x, this one is x, current passing through C is 3x. That would be the total current. Because the total current in a parallel circuit is the sum of currents from all the loops. So I'll get rid of this upper part to show you what I mean. And it's taking forever to delete this part. So current through C should be given by x plus 2x, which is equal to 3x. This implies that current through C is equal to x, which is 1 amp, plus 2x, which is 2 times 1 amp, which is equal to 3 amp. So we are saying this loop here has 3 amp of current. So we start with 3 amp of current, and the current will divide here. 1 amp goes this way, and 2 amps go this way. That's what happens. But the total, the source here, we have a current of 3 passing through the source, and then when we come through this junction, we divide. 1 amp of current goes through R2, and 2 amps of current go through R1. And we are saying that a parallel circuit has a current divider. Now let's move on to the next problem. In the diagram below, R1 is 200 ohm and R2 is 400 ohm. If a voltage of 4V passes through R2, how many volts does the voltage source V have? So the first thing is a statement: there is no voltage divider in a parallel circuit. So there is no voltage divider in a parallel circuit. This implies that voltages are the same everywhere. So voltages are the same everywhere. So the question is, if 4 volts passes through R2, so this is R2. So we are saying we have 4V here. How many volts does the voltage source V have? So the answer is voltages are the same everywhere. If 4V passes through here, 4V will also pass through here, and the voltage source will also have 4V. So the answer is the voltage source has 4 volts because there is no voltage divider in a parallel circuit. Let's move on. What is the ratio of current passing through R1? What is the ratio of current passing through R2? So to find the ratios of current through R1 and R2, we still need to take note that R1 or R2 is double R1. So R2 is double R1, which means the current passing through R2 must be X, and the current passing through R1 must be 2X. Because the reason is current is inversely proportional to resistor, which means I is equal to 1 over resistor. Or you can say resistor is equal or is proportional, not equal. Resistor is proportional to 1 over I. The bigger the resistor, the smaller the current. So R2, which is double of R1, must have a current of X, and R1 then must have a current of 2X. So this is 2X, this is X. But when you add the two, this path here must have 3X. So we start with 3X here, and then X goes this way, 2X goes that way. So we are trying to find the ratio. We are saying we have 2X plus X to give us a total of 3X. This one is for R1, this one is for R2. So the question is, what is the ratio of current passing through R1? So the ratio is found by the current passing through R1 divided by the total current. So current through R1 divided by the total current, which in this case is 2X. The 2 does not look good. Which is 2X divided by 3X. which is 2/3. So the ratio or the fraction of current passing through R2 is 2/3. So 2/3 of current will pass through R2. What about the ratio of current passing through R1? So this one is the same thing. Current through R. What is the ratio of current passing through R2? It's the same thing. Current through R2 divided by the total current, which is X divided by 3X, which is 1/3. So these are the two ratios. 2/3 passes through R1 and 1/3 passes through R2. So if you add the ratios, it will be 2/3 plus 1/3 to give you 1. That's how we solve these problems. Why did I give you these problems? So I gave you this ratio problem on purpose so that you understand what are the ratios. If we start with current and the current is going through 2 loops, one loop has double the resistance of the other loop. You need to know that 2/3 of the current goes to the small resistor and 1/3 of the current goes to the bigger resistor. And you can use these ratios to make calculations. Let's see. We have our ratios and you want to make a calculation using the ratios. In the diagram below, R1 is 200 ohm and R2 is 400 ohm. If current of 2A passes through the voltage source, that is the cell, how much current passes through R1? So we have 2 loops here. Current of 2A passes here. But we want to find current passing through R1 and R2. We want to determine current passing through here and current passing through here. How do we solve this? We go back to our ratios. So what do the ratios say? From the previous problem, we know that 2/3 of current passes through R1, which means R1 has 2/3 of the 2 amp current, which is 4/3 amp. So you can divide that one to get the amps, or you can just leave it like that. So R1 has 4/3 amp. You can reduce this one because I don't have a calculator on me, but it should be 1 1/3 or something, 1.333. So I'll say it's 1.33 amp passing through 1A. Once you know the amps passing through R1, the amps passing through R2 will be 2 amp minus 1.33 amp, which will be 0.67 amp. So we are saying that of the 2 amp you are starting here, 0.67 let me just so of the 2 amp you have at the beginning, 0.67 amp goes here and 1.33 amp goes here, and you can see that we have used our ratios based on this problem. We have used the ratios that we got at the beginning there, so you really need to keep these ratios. You can also use the ratio for resistor 2. If we go back to our ratios, we can say current passing through resistor 1, we know that 1/3 of current passes through R2. Then we can say 1/3 times 2 amp is equal to 2/3 amp, which is 0.67 amp. So once we know that R2 is 0.67 amp, we just subtract 2 amp minus 0.67 amp to get R1. So that's how we solve these problems. So just go over them and understand them. Thank you.